Hi there. So, according to IB, you need to know this. So, this is an algorithm. You need to be able to explain the concept of an algorithm, explain the key properties of an algorithm, and describe the ways used to express an algorithm. So, you also need to know, well, so first of all, the definition, let's just read it. So, an algorithm is a series of unambiguous instructions designed in order to solve a problem and achieve a certain goal in a finite number of steps. So, in kind of natural language among humans, actually, even when you're talking about something like math, um, sometimes like what the symbols mean or what the word means depends on the context that you're talking about. So, for example, a Mustang, if I say draw a picture of the Mustang next to the house, I might mean a car or I might mean a horse. So, for a computer or a robot or a device, your instructions have to be unambiguous. They have to be absolutely clear. Um, Design in order to solve a problem, achieve a certain goal in a finite number of steps. So uh, it can't be infinite. So then, according to Knuth, 1968, an algorithm must possess the following properties. So finiteness, so it must terminate after a finite number of steps. Um, Definiteness, each step of an algorithm must be precisely defined. The actions to be carried out must be rigorously and unambiguously specified for each case. So we talked about that. And again, we did the peanut butter and jelly sandwich activity in class, and you can see, if you say to a human, "Hey, open the peanut butter," the human's going to understand that. If you're trying to tell a robot arm to open the peanut butter, um, it's something else entirely. That the robot, you know, needs to know where to go with coordinates or some other mechanism, and it needs those instructions spelled out just in a way that you're almost never used to having to do like with a person. Okay, input quantities which are given to it initially before the algorithm begins. These inputs are taken from a specified set of objects. So in the peanut butter and jelly case, you could think about this as our initial place setting. Everybody started with the bread, the knife, the peanut butter, and the jelly in the same position. So we all had the same input um, before we did our definite sequence of steps on it. Output quantities which have a specified relation to the input. So that's the kind of uh, process that comes out. Like I guess in the case of the peanut butter and jelly sandwich, if we had a robot arm, the output would be like, do we have a sandwich that's made, or do we have like stuff stuck all over the place? And then finally, that it's effective. All the operations to be performed must be sufficiently basic, and they can, in principle, be done exactly in a finite length of time by a man using a paper and a pencil. Um, okay, so a good model for an algorithm, it's a recipe, for example. Um, it's easy to write a recipe for a boiled egg. Now, here they have an example for an omelet, and et cetera, et cetera. You can freeze that if you need to, but that's not really the important point. Um, but down here, and this is part of the IB standards, you need to know that there are a number of ways that we can express an algorithm. So we could use simple English or natural language. So that's kind of how we did this with the peanut butter and jelly. You could use a flowchart, which is a graphical representation um, of how the algorithm works. So pseudocode, a generic artificial language that is designed for humans to be read, um, rather than a computer. And then finally, a programming language, a specific language like Java. So these are four ways that we could express an algorithm. And the way the IB test works, like you might need to be able to say that. So the four ways: simple English, natural language, a flowchart, pseudocode, or like an actual implementation in a programming language like Java, Python, or Scratch. Okay, thank you.